Hello and welcome to this section of the Matlab tutor. We're going to continue working with vectors. Specifically, we'll learn about the very important functions dealing with the dot product and the cross product and how they apply to vectors. Now, the dot product is what we'll talk about first, and there's another name for that you may see in books. It's called the scalar product. So if you see scalar product or dot product, it's really referring to the same thing. So let's go ahead and set a couple of vectors up here. Let's set vector A is equal to something easy to deal with, something like this. And we'll do vector B, and we'll set that equally easy to deal with. 1, 2, 3, just so we can see what's going on. So we have two vectors, same size, and we'd like to dot them together. The way you do that is you use the function dot. There's actually a function for this. So you type in dot, and then A comma B. In fact, it's trying to tell you right there. You have to type your vectors in A comma B. You hit enter. You would expect to get a single number back because the dot product or the scalar product, same thing, always returns a number, a single number back. So what's happening here mathematically is Matlab is taking 3 times 1, and then it's taking 5 times 2, and then it's taking 7 times 3. It's getting all of those results, and it's adding them all together. So that's why we just get a single number back. The dot product, the function dot product here that we're doing right here. Let me create another vector here, C. We'll do, 4, 7, negative 33 or something like this. The function dot here is very, very easy to use. You could do C, comma, A, which, by the way, is exactly the same as dotting it the other way around because of the way you're basically multiplying elements and adding everything together. So when you do the dot product, it's the same thing no matter what order you put the vectors in. This function works fantastic. I really recommend you use it. But I want to take just a few minutes to explain a little bit deeper about the dot product in Matlab here, because I want to show you a different way to compute it that you may not use right away if you're super new to Matlab, but as we start talking about matrices and as you start using the program more, you'll realize that what I'm about to tell you actually makes a little more sense as far as how Matlab works. All right, so let's pull up our A vector. That's what it looks like. Let's pull up our B vector. So most students, when they first sit down to Matlab, will define these vectors and try to dot them together like this, A times B, because it kind of makes sense. I mean, we almost kind of write that down on paper with a dot between the vectors A and B when you're working on paper. So you would expect Matlab to be able to work with that, but it doesn't know what to do. And it says inner dimensions must agree, and most people look at that and don't have any idea what it means. What it's basically trying to say is, stop thinking about these vectors in terms of vectors. That's what I was trying to tell you before. Start thinking about them in terms of a matrix, right? A matrix. It's just that matrix A here is one row, and matrix B here also has one row. So if you think about matrix arithmetic, right? How do you multiply matrices together? If you can kind of visualize in your head a matrix right here where I'm circling right here and then another matrix right next to it, the way that you multiply matrices is you have to go across one matrix and then down the other one. And then you go to the next row, across and then down, and then across and then down. And what you're doing is you're multiplying each element and you're summing them together. That's how you do matrix multiplication just in math. That's nothing to do with MATLAB. That's how you do it on paper, right? So if you forget about these things being a vector, when I type something like A times B in, it's taking matrix A. Of course, we're calling them vectors, but I'm also telling you they're simplified matrices. And it's trying to multiply it times basically matrix B. And when you line these things up, what we have is we have a horizontal A vector and then a horizontal B vector. So you can't, using the rules of matrix math, you can't multiply across and then down because they don't have the same dimensions. In order to do matrix multiplication, you have to multiply element by element across and then down the first column of the other matrix, and then across and then down, and then across and then down. So whenever you try to do it with vector A and B, the dimensions don't work because both vectors are lying on their sides, so to speak. So let me introduce something to you that you work with a lot when you deal with matrices, and that's called the transpose operator. So what if I show you B matrix? This is B matrix. Now if I put a little quotation, a single quote, it's right near the enter key on your keyboard, right next to B, and hit enter, what it does is it takes the vector and it makes basically the transpose of it, which means all of the rows become columns. And this works for matrices also, we'll learn later, but this is just a simple vector, which is just a single row matrix. So it takes this row and it makes it into a column. So let me clear the screen and let me just spell it out for you. Here's vector A and here's vector B transposed. It's the same elements of B. Everything's the same. It's just orienting those elements in terms of a column. So now if you can visualize vector A being here, and then the transpose of vector B being right next to it, you could multiply across and you could multiply down, going element by element across and down. And that would give you a single number. It would be 3 times 1 plus 5 times 2 plus 7 times 3. That's what it would give you, right? So if I actually do this, A times B transpose, and hit enter, the answer I get is 34, which is exactly what I get if I type in dot product A comma B. I get 34. So sort of that's the punchline with vectors. One of the most important and common things you will ever do with vectors is learn how to take their dot product, right? So there's two ways to do that in Matlab. If you want to use the function, just type in dot product A times B, or A comma B, and it'll compute the dot product. What it's doing is going element by element, multiplying and adding everything together. Or if you're a little more comfortable with Matlab and how it works, you'll realize that you can't do this because the dimensions aren't right. So for vectors, what you'll need to do is something like this. And by the way, the exact same thing works if we go B times A transpose, because everything is summed together. We're basically multiplying the elements and adding them up, so it doesn't really matter the order in which you do them, if it's A times or A dot B or B dot A. So this is another way of doing a dot product, is the short answer to that. You multiply times the transpose of the other vector. I hope this makes sense to you. I'm trying to ease you into how Matlab really works as far as the fact that almost everything is basically a matrix at heart. Hopefully this makes sense to you. If it doesn't, just forget about it for now and just use the dot function. So let me go ahead and clear the screen. To do a cross product, things are pretty easy. There's actually a function called cross. And so if you want to do the cross product of two vectors A and B, look, it's trying to help us there with the help. You just close it off, and then what you'll get for the cross product is a vector. Remember, dot products return a number. They return a scalar quantity. That's why they call it the scalar product. Cross products return a vector. So it just so happens, so if this is vector A and vector B down here that I've got below, the cross product of these two vectors, if you think about it in terms of x, y, z, this is x, comma, y, comma, z, right? X direction, y direction, z direction, x direction, y direction, z direction. So these are two vectors here. Their cross product produces a third vector. The direction of this vector should be perpendicular to vector A and perpendicular to vector B, and that is by definition what it is. MATLAB does all that stuff behind the scenes. So I just wanted to introduce the dot product and the cross product to you here because they're so central to engineering and science and math. You use them constantly. For the cross product, just use the function here. For the dot product, it's very easy just to use the function here as well. But as you get more and more into MATLAB, you'll get more comfortable with what's going on, and maybe using this function isn't quite so convenient. Maybe you just want to represent it as sort of like a multiplication. And when you realize that what's happening behind the scenes is just treating everything in terms of matrix arithmetic, then going across and down with the multiplying and the adding, that's exactly what the dot product is. So I wanted to show you that as well. So that's going to wrap up this section. Go ahead and play with this. Make sure you understand it. Follow me on to the future sections where we'll continue working with vectors.